Assumptions of Max Planck, or we can say that postulates of Max Planck's. First, energy emission discontinuously due to presence of atom. Now, as I taught you recently that the radiations are discontinuous due to meta state. Second one is that a body absorbs or emits energy in form of discrete wave energy packets. Now, as I taught you, the energy released or gained by the atom is quanta. Now, Max Planck also said that those energy are known as quanta, or that was the Planck's quantum theory. The third one is that energy of photon or energy wave is directly proportional to frequency. Now, we know that one rotation or one thrust and trough in 1 second at the time duration of 1 second is known as frequency. Now, Max Planck says that the energy in form of a wave or a photon or quanta, whatever, that is directly proportional to frequency. Like we can say that E is directly proportional to frequency. If the energy increases, the frequency also increases. If the energy decreases, the frequency also decreases. Now there are some formulas that are derived from Planck constants, or we can say that are related to the energy emissions. First one is, I taught you, E is directly proportional to frequency. Energy is directly proportional to frequency. Now here, when we remove the proportionality sign, we will place H, Planck constant here. Now the Planck constant's value is 6.62 10 raised to power. Now here let me write it. 10 raised to power minus 34 joule per second. That's the unit to just calculate the energy. Joule per second. Now this formula is formula of energy with respect to frequency. If frequency is given to you and you have to find the energy, you will put this value or this formula. Here the H is constant. Now let me just remove that. Okay, fine. Okay, now the frequency is directly proportional to wavelength or lambda. Now here, when we remove the proportionality sign, we will place the C, speed of light here. Now why frequency is inversely proportional to lambda or wavelength? Now we know that if the frequency is high, the wavelength is less. If the wavelength is more, the frequency is less. That's why it is inversely proportional. Now here we know that the speed of light is equal to 310 raised to power 8 meter per second. That's the speed of light. This formula is of frequency with respect to wavelength. Another formula is of energy with respect to wavelength. Now energy is also inversely proportional to wavelength, as energy is directly proportional to frequency. So it's it's a common thing that if energy is directly proportional to frequency, it should be inversely proportional to the lambda. Now here, when we remove the proportionality sign, we're gonna add here the Planck constant, speed of light plus lambda. Now how we just put that? We know that H, E is equal to H and V. Now the formula of V is C upon lambda. That's why we just put it here. Now this is formula of energy with respect to wavelength. Now here is another term, energy with respect to wave number. Now when we remove the proportionality sign, we're going to place here h and c, speed of light and Planck's constant, with multiplied with wave number. Now we know that wave number is pretty relatable to the frequency, so it is also directly proportional. Now it is understood that if wave number is same as frequency, so it must be inversely proportional to the wavelength. Now when we're going to remove the proportionality sign, we're going to place here the c, speed of light. Now that's the formula of wave number in terms of wavelength. And that's all about today's lecture.